Alright, so today we're looking at linear functions. So we want to gain the knowledge of what a linear function is and some of its features. So we'll be successful if we can identify what a linear equation is. It is a direct variation or direct proportion of the form of how it may appear, a linear function may appear. We want to be able to identify the domain and range, and we want to be able to calculate x and y intercepts. Okay, so what I want to talk about is direct variations. Well, I want to talk about a couple of things. So in year 9 and year 10, we would have done linear relationships, and you would have seen this y equals mx plus c. You may have learnt it in year 9 or year 10, linear relationships. You might have learnt it as y equals mx plus b. Alright, where m is your gradient of the line and b was your y-intercept. Okay, and that's fine. All we have done now is we've actually changed the letter. So rather than b, we've changed the letter to c. You can kind of think of it as a constant, yeah? So that's m still your gradient, and c is what we're calling your y-intercept. Okay, so we just changed the letter. That's what we've done. All right. Let's talk about the general form. So the general form is when we write the whole thing all on one side. So it's where we get all variables onto one side, but the x comes first, and the x has to be positive. So if I was to rewrite this, I'd have mx minus y plus b, bringing the y over, equals 0. And that would be the general form. Okay. Direct variation. Well, these linear functions can obviously be drawn as lines. So, and what we call a direct variation is where where the variable of x increases, so does the y. Yeah, so that's a direct variation. It will be multiplied by a constant or proportion. And we usually have that constant represented as the letter k. Okay, so we'd have y equals some k of x. Okay. Yeah. All right. So let's do some examples. Okay. I've got 3 functions here. I've got 1, 2, and 3. We're going to do A, B, C, D, E, and F for each one of them, but I'll probably flip from them. So, for example, if I start with this one, f of x equals 2x plus 3, and I ask you to sketch the function, I'm going to use this stuff here to figure out how to sketch it. Okay, so let's figure out first, what is the x-intercept? Well, the x-intercept happens when the function, when y equals 0. Okay. And solving this, I get negative 3 over 2x. I get x equals negative 3 over 2, or negative 1.5. Okay. So what's the y-intercept? Well, that's when x equals 0. So y equals 2 lots of 0 plus 3. And that gives me 2 times 0, 0 plus, it gives me 3. Okay. So what I'm going to do is I'm going to use these two things to draw my line. All right. It's a sketch, so it's not to scale. I've got my x and my y axes. Okay, my x-intercept happens when it's negative 3 on 2, so negative 1.5. And my y-intercept happens when y equals 3. Alright, got those 2 points. As I said, it's not to scale. Alright. Put my arrows on and write down the function. Okay, so maybe that's one thing I want to talk about. So the direction. So if your graph is going up this way, it is positive. If your graph is going down, it is negative. So the gradient here is positive, and here the gradient is negative. So for example, this one, the gradient would be positive. Okay, so what is it in the gradient intercept form? Well, there's your gradient, the 2, and there's your intercept, 3. So we can either leave it as f of x or y equals 2x plus 3. If I want it in the general form, all right, my 2x is positive. I'm going to bring over the y. The 3 stays on the same side and set it to 0. Okay. Now, the domain and range of a linear function, because I don't set or haven't stated what area I'm concerned about, the domain for most linear functions is going to be from negative infinity to infinity. Yeah. And so is the range. Okay. Let's look at the next one. We've got this y equals 2. So what happens is this is just purely a straight line at y equals 2. So here's my sketch. So this is x axis. There's my y axis. Here I've got the point y equals 2. So all points of x, I'm going to produce a value of 2. Okay, so the x-intercept in this situation, it never crosses the x-axis. So there is no x-intercept for this one. Yeah. The y-intercept, however, is at y equals 2. So the y-intercept is at y equals 2. The gradient, well, there's not really a gradient, so the gradient intercept form is still y equals 2. Yep. The general form would still be, y minus 2 equals 0. The domain, well, all x values, the domain for this situation would be from negative infinity to infinity, but the range is only at 2. Yeah, the range just stays at 2. Okay. Here's my next and last function. I've got minus 2x minus y plus 4 equals 0. All right, the first thing I might want to do is I'm probably going to want to do it and put it into the gradient intercept form. So if I take that y over here, I get y equals negative 2x plus 4. Okay, because this is already the general form. It's not so much because I really need to move I need to move everything over to this side to have x positive. So it would be 2x plus y minus 4 equals 0. Okay, and that's the general form. All right, so what would be my x-intercept? So that's when y equals 0. So I get this. Okay, so I get negative 4 divided by negative 2 is 2. Okay, and then my y-intercept is when x equals 0. So that would be 0 plus 4. I get positive 4. Okay, so if I was to sketch it, should have written this as well. All right, just to sketch it, I've got an x-intercept at 2, and I've got a y-intercept at 4. All right, joining the dots, I get this line here. It's a negative gradient. It's going down. And there's my function. All right. So in this situation, once again, I have a domain that goes from infinity to infinity. And here I'd have a range that also goes from negative infinity to infinity. Okay, so reminding our success criteria, understand what direct variation and direct proportion, so a proportion of k, constant proportion. We have the y equals mx plus c, or the general form ax plus by plus c equals 0. Able to identify the domain and range of a linear function. So predominantly, most of it's going to be from negative infinity to infinity, unless we have horizontal vertical lines, or unless we specify the domain that we want. And then we can calculate the x and y intercept. So the x-intercept happens when y equals 0, the y-intercept happens when x equals 0. Okay, good luck.